So, a warm good evening to everyone. I am pleased to read out the profile of today's distinguished guest. Dr. Asadi Srinivasulu is a renowned academician, researcher, and industry expert in computer science and engineering, boasting 22 years of experience. With a strong educational background, including multiple PhDs from IIT Hyderabad and JNTU Anantapur, he has established himself as a leading authority in his field. His expertise spans data science, artificial intelligence, machine learning, cloud computing, and software engineering. Dr. Asadi has published over 196 papers, authored 8 textbooks, and guided 8 PhD students. He serves as a visiting professor at CRC Care, University of Newcastle, Australia, and has received prestigious awards including the Bharat Vidya Ratan National Award and Lifetime Achievement Excellence Award 2022. Unfortunately, as an emergency health issue, Dr. Asadi scholar, who is a postdoctoral fellow, Dr. Polaya, would be presenting on his behalf. Let us hear him. Thank you.
Thank you for giving your valuable time also. Really, I'm very happy regarding this. Dear participants, for the this session, I'm welcoming you. So I'm welcoming once again on today's topic, that is artificial intelligence or machine learning based application in semiconductor design. So I'm going to take this session on behalf of our beloved my Guruji, our Asadi Srinivasulu, and who is here given me some more detailed information which I want to share today. Those are first of all, I want to clarify about fundamentals of sensor-based semiconductor materials and how we are going to be used AI or ML in semiconductor design. If at all we are using design, how it may be follow the data-driven semiconductor design, and also I am extending my knowledge in how we may be design such a semiconductor material circuit design in terms of automatically by using AI program. So of course we are all aware about artificial intelligence, that is today uh, the complete generation to generation are using. But here still we have in artificial intelligence some more limits. Those limits are will be uh, overcome by the help of the subset of AI, that is deep learning for chip defected detection. Of course, we are going to be use the deep learning as subset of AI, which is may going to use ML machine learning, and the machine learning subset will be deep learning. So that one we may extend it not only for the chip defect detection, but also we are going to be have fault prediction in semiconductor manufacturing. So these are all the topics which we are going to cover within another 1 hour. And before I'm going in detail about this AI ML application in semiconductor design, let me to have some what we called the fundamentals about our semiconductor materials. So these are the semiconductor materials which we want to concentrate for designing of semiconductor. So coming to the, I want to concentrate some of the materials on based on the semiconductor junctions. As you know, the semiconductor junction nothing but there are diode junctions and transistors junctions, which we may know as the electronics background knowledge is. Those are we are preparing in terms of some of the thermometers. Based on semiconductor junctions, and also we are concentrating magnetodiodes and magnetotransistors. So where we use number of applications at present technology, those we called as photodiodes as well as phototransistor, to minimize the chip, what we call chip size. So that means to fold interest of sensors based on semiconductor junctions, we are here to concentrate on large yield of microfabrication process results in competitive price, as well as we are going to be concentrate on when we are preparing such a chip process, we are going to be understand in terms of the type of sensors, the way we are connecting the signal conditioning signal processing, and communication circuits to produce intelligent sensors. The meaning of here sensor is one type of material which we are going to be used for the preparation of signal conditioning as well as signal processing and communication circuits. So coming to the point here, how can you are going to be fabricate such a semiconductor materials as we consider thermometers based on semiconductor junctions? The diode configuration, the forward characteristics of a diode is a temperature dependent, which is generally a limitation here that is used in the principle that depends can be used to measure temperature or any other quantity related to change in temperature limitations. It is not linear and not repeated for accurate measurements. We are going to be used the basic principle of diode configuration, which is the diode is subjected to heat. The change of temperature gives rise to carriers that in the sense thermally generated. Those that already present will attain in terms of energy when that is enough to overcome the potential barrier. The electrons across the that in the sense electrons cross over and increase the current. So this the basic principle and which we may extend in terms of relation between temperature and the increase of current is used in the detection of temperature dependent on material and change in temperature. And coming to the transistor configuration, which we can compare with the diode configuration. So transistor configuration is the major and basic principle is here working to photo in terms of photodiode. A temperature dependence of base emitter voltage or current is considered. So configurations in the sense the way you are preparing circuit that you are going to be select a transistor in terms of as we are all aware of that types of configuration either in PNP or NPN or combination of both we can be prepared. For example, the configuration which can be depends on temperature of a base emitter voltage with a constant collector current would be used. Two bipolar transistors whose emitter current densities have a constant ratio. Two transistors with different emitter areas but with the same collector current may going to be used in terms of single transistor with the switching of two known currents and subtract respective voltages. So, and we are also extend that the principles of both in terms of uh, diode based and as well transistor based. Let you see here how the transistor based we can be prepared by using this circuit. So this is the circuit which we prepare under the your technology which we are using at present for the sake of semiconductor memories devices. As you all of you know, the memory device which we are preparing for the digital system preparation. So obviously we may be prepared such a circuits. So as we have here the thermometer based upon the temperature dependencies of the base emitter voltage in a bipolar transistor that is here base emitter and the bipolar transistors which we are using Q1 and Q2. The both we are connected together and concentrating on the way we are connecting here dependence on the base emitter voltage only. The use of current sources uh, with a given ratio make it necessary to have a stable reference current and provides an increased line array. The circuit for current sources of minimum of 5 microamperes and 10 microamperes if you want you can increase by the help of sensing pair. So this is that circuit actually. So here we are using the combination of both that resistances of values which we can be increases or decreases in terms of variable resistor and with the amplifying will be increase approximately the 10 microamperes based on the your voltage. So this is the circuit basically which we are preparing for preparation of a type of material. Of course, we are going to be prepared such a materials in terms of simplified circuit for a temperature to current converter, thermometer with at least 1 millivolt per kilo output, or a circuit to detect the minimal temperature. That is what we are seeing here, one circuit to the another. So first circuit is temperature to current converter. The second circuit is thermometer with 1 millivolt per kilowatt output, and the part is, that is another circuit to detect the minimal temperature, minimal temperature controversy of analog devices. So coming to the what I want to extend my knowledge is here, we are so-called preparation of semiconductor devices as today we are constructing such a diode-based and transistor-based semiconductor memories devices in terms of sensing, in terms of memorizing. So that we are preparing. But this is conventional way which we are preparing the circuits and analyze the signals. But where the current output is the advantageous for remote measurements in terms of prevalent interference voltage due to capacitance interference do not noticeably affect the measurement condition that low impedance of detecting circuit. So by seeing these two circuit of configuration for getting voltage output and sensors in series to get output voltage proportional to minimal temperature. So by the understanding such a circuits, the major advantages are here. We may have less expensive than RTD and more linear than thermistors and thermocouple, high output than RTD or thermocouple. What do you mean this? These are the materials which we are preparing, more fundamental materials which are using at present in terms of RTD and in terms of thermocouple where we are using in our day-to-day life also. So, but it has certain limitations to reduce the some operating range in between minus 55 degrees Celsius to 150 degrees Celsius. As you all know, even I'm using right now my laptop, it is right now showing some heat sink. So, how can I reduce it? How can I maintain in terms of less accurate and less linear than the less linear and less linear than RTD. Slow response than barrier thermocouples. So often we may proceed such a thing in the sense we are going to have the different applications point of view. Number one, the temperature controllers, as we are using at present even remote controls based ACs, thermostats, that is one of the application, and the another one is here we are going to be used, that is HVAC systems, thermal protection in PCs, industrial process control, temperature probes for digital multimeters. If electrically insulated, they can measure temperature of operating active components. Use it for temperature coefficient the compensation, cold junction compensation in thermocouple circuits, IC sensors with integrated window comparator for temperature control. Somehow it is ADC integrator also, analog to digital control, analog to digital converter integrated circuits. So these are all the most applications which we are concentrating on semiconductor materials products. Okay, coming to the semiconductors also can be used in terms of magnetodiodes and in terms of if at all use the magnetodiodes, so how it may be used in terms of in our day-to-day life. Let me see this in a magnetic field perpendicularly to direction of a travel of charged carriers. Of course, you may be notice that IV characteristics for a diode changes because of Lorentz force derivations from such a trajectories. If a diode is constructed such that it carries the or deviated to high recommendation region in terms of IV characteristics depends on magnetic field intensity. The sensitivity to magnetic field increases if recommendation characteristics are low and high recommendation regions differ significantly. This is the major part of our magnitude diet. What I am telling is here, before I am using my AI/ML for preparation of such a semiconductor materials, but let us we have to have minimum what we call as such a memory, such a semiconductor materials. How can we prepare in our laboratories? And present we are so called we may use such a diode or a transistor based of IV characteristics preparation happen, but those still it needed some more advanced technology that we are going to be connected by the help of AI. So before I'm going to connect this semiconductor materials preparation by the help of AI ML, let me to have two more slides about this magnitude transistors based also. So magneto transistors is also one type of material. It works on the same principle as magneto diodes, different from where we can configurated or available in terms of emitter base collector combinations. Of course, you all of you know we may be formed in terms of emitter such a transistor, not in a general transistor way, but the required transistor based on the collector current, we can form emitter base and two collectors. If suppose you want to form in terms of voltage to collector currents combination, we may use the basic principle of Hall element with two transistors. Of course, we all often know the gate voltage which we may be prepared by the help of field effect transistors and metal oxide field effect transistor, MOSFET and FET. So how we may be prepare such materials also is also using Hall effect with the two FET. Then we may get to gate voltage. So what I am saying, I am extending the knowledge about this general discussion and the more fundamentals which we all of you know, being a teacher, being a had some more knowledge regarding this transistor, which we can prepare by the three terminals, emitter, base, and the collector, in terms of uses based on the different regions, in terms of very general way we may be prepare. As you already may know, CB configuration, CC and CE, something we can prepare such a type of configured materials. Whenever we concentrate on no magnetic field in between two collector currents are given, then it may be equal, which in terms of magnetic field towards to one collector current increases while other current it will be decreases. The difference between these currents is measured based on the we are concentrating on applied field intensity because we are preparing is a magneto transistor. So and I said here, though we are using Hall effect, Hall element with transistors based principles, what we can see this here we can also see that the Hall element is the basically base common to both transistors has two contacts, one at each base. When magnetic field is applied, Hall voltage is formed between both contacts and as well as the base voltage for one transistor is larger than other resulting in collector current imbalance, which is a measure of applied field. So the limitation concentrating on not yet found a broad commercial use, but poor reliability, low intensity, low sensitivity, offset problems, not compatible with standard IC process. That is, IC means integrated chip process, where it is very expensive. So these are the limitations when we concentrate on magnetite transistors. But whereas these photodiodes are can be used in photovoltaic mode or photoconducting mode, which is having a basic principle in terms of when internal photoelectric effect occurs in a PN junction, a voltage or short circuit current is generated, that is a junction of incoming radiation intensity. Instead of using such a photovoltaic mode, it is used as in photoconductive mode with an inverse bias voltage 5 to 30 volt to the depletion region, since non-depleted P and N regions are conductive. So this increases width of depletion region and yields a faster response time and a current proportional to radiation intensity. How it may be happen that PN regions, let you can also see this simple diagram which we already have photodiode structure showing in terms of depletion region and then thin P layer. That is, you are going to use your regions based such a region spaced here SiO2 region is here. Such a oxide diffusion mask is applied. How this structure may be getting in terms of incident radiation absorbed, and we may concentrated generated in the P and N regions for getting the correct output current. Charges have to migrate surface. It slows response time and results in recombinations and reduces sensitivity response. So I'm here, not boring you all of you, because I wanted to first of all, before I'm applying AML for preparation such a characteristics of concentrated photodiode product by the A or ML or DL based design. Let me have first of all some more fundamentals regarding this photodiode is a square pulse of radiation. How it may be happen? Let us easily take x-axis, which is we are taking time based, and y-axis will take in terms of either current or voltage variations. For example, 0 volt, no polarization and response is very slow because of slow charge migrations. Whereas if it increases 5 volt, what happen? You see sudden changes are happen, and this quickly collected in depletion region in between P and N regions, which we are gone through the here. So charges produces outside the depletion region migrate slowly, causing the slow response part. So such a one we have observed in between P and N regions with the 5 volts changes. Whereas 30 volts changes we may going to be used in terms of depletion region extends entire depth, but results in fast rising edge. That is what we can observe from this characteristics. And we also extend our the concentration of semiconductor materials in terms of different models which we can be prepared. Pin diode, that is achieved by placing a region of intrinsic semiconductor between P and N regions, forming PIN diode. So where I is nothing but we maybe knows that it is intrinsic region in between P and N regions. That is we call as pin diode. Has less recombinations rate. Also has less internal capacitance because of increased separation between doped zones, increased sensitivity and spectral bandwidth. So avalanche multiplication also we can consider here as one of the parameter for the sake of voltage applied, making towards to photodiode operate near breakdown and causing a chain reaction termed in terms of AM. So this amplifies the basic photodiode current by up to 100. Permits that low light measurement and high speed measurement in terms of affected by tolerances in bias voltage and diode characteristics required individual circuits adjustments. So the things to consider based on our discussion of pin diode, it is a response depends on observation of its window and also on detecting material itself. Silicon cannot observe or detect wavelengths longer than 110 nanometers. Short wavelength may not penetrate surface, so thin surface may be required. Loss due to absorption in entire reflective coating in terms of the response and its response required ones. So the detecting windows are selected to improve the desired response in terms of maintaining our plastic window filters of values in terms of radiation in between the range of 150 sorry 850 nanometer to 1000 nanometer. So lambda value is right now helps us to understand about the radiation transmits radiations where we are going to use such a what we call materials in terms of germanium. If you use then germanium transparent from instead of 850 nanometer, it may be concentrated only from 800 nanometer to 1800 nanometer. So photodiodes are available in range of zero point 0.2 micrometer to zero point 0.2 micrometer range of materials. So of course, the fundamentals which I'm closing right now by the help of some of the sensors which we are using in terms of color sensors or the standard color sensor. Color means RGB. So R is red, B is blue, G is green. Such a filters which we can be used in determining by current generated by light transmitted through filter, also attenuation lights of desired wavelength. The attenuates nothing but the resistance which we can be tuned based on the your required in terms of a transparent window and the two stacked pin prototypes. Whereas the spectral response depends on voltage differences applied to them. Sequentially applying these differences bias in terms of three different bias voltages, it can be check the intensity of three basic colors. So these are the colors. You can also observe that photodiode equivalent circuit and where we can be use RGB colors in terms of your maintaining the your values resistance and the current relations. So these are the IV characteristics of for a photodiode where it is varies. And limitations also it has some of the photodiodes which are uh, presence of thermal noise and short noise, sensitivity to temperature, sensitivity to bias supply fluctuations. But it has a more advantage in terms of increased response speed as compared to photoconductive as well as increased band. So I'm comparing here, which we based on our discussion of simple principles and its characteristics as well as limitations. Those are what do you mean be the major difference between photovoltaic and photoconductivity or photodiode. Photovoltaic, if it maintain in terms of sensing, active sensing or generated voltage or current, but whereas in photoconductivity, it is passive sensing, require voltage as well as or our current supply. But here in photovoltaic, we have no DC bias, it is having DC bias reverse. No leakage current noise and leakage current noise present. Less bandwidth, high bandwidth, slow response, fast response. Require amplification, only few required amplification. High diode capacitance, low diode capacitance. Why I write these differences in this sense? Before we are applying AI, we have to concentrate specifically the parameters values which we are making for the preparation of either photovoltaic diode or a photoconductivity or photodiode. Okay. So next, different applications also we have to concentrate, but for the sake of this based on AI or ML based semiconductors which we are preparing for usage in optical communications devices, photometers, illuminations, brightness control, infrared remote control, distance meters preparation, thickness gauges, optical observance measurement, which are we are using such applications very widely at present, even not only in automobile but in our hometown or even in traffic light signals preparation also. So we also applied such a count bills in shorting missions also. Ultraviolet photodiodes are used in spectroscopy, photometry, fluorescence analysis, as you know, UV intensity and exposure metering for, detecting for detecting gas and oil flaming monitoring. We are using semiconductor only. And as well as we are preparing such a semiconductor based on color sensors used in production in terms of inspections and quality control. Photodiodes arrays used in linear and rotary encoders, barcode readers, edge detections, positioning, imaging, and paper handling. That in the sense, optical character recognition or document classification or copying missions. Uh, what we call the face mail. So we are using such a semiconductor devices on. And also we can extend some more important applications which are using at present, especially in modern cities. Those are automatic focus and exposed control in cameras, as we are using in terms of what we call the uh, what we call in present days in the mobile phones. But I may not using such a what we call as such applications where we can use more and more in what we call our uh, mobiles based technology also. Let me extend some more fundamentals about semiconductor materials, which are we can concentrating on photo transistors. It is integrated based off the combination of photodiode as well as transistor. You know, you have there are different transistors, maybe PNP or NPN transistor, but I am taking here PNPN transistor, which are optical illumination, and uh, uh, that if you consideration optical radiation emulates the base, that is collector current is IC is equal to beta plus IP plus IT. So IP is equal to that is your collector current, which we may be concentrating on towards to detector in terms of electron hole pairs generated per second divided by number of photons incident per second. What do you mean the relationship of this mathematical model as a considerable equation for preparation of your semiconductor design based on AI program? That program also I am explaining very soon. So Q is the charge of an electron, phi is their incident flux density, A is the sector area, and S is sensitivity, which is respective of semiconductor based materials. It may be changes. P is your incident power value. So with this, uh, I want to extend some more equations. Of course, we have a lot of materials which can be used in photoelectric sensing modes, opposite reflection, proximity. These are all different types of materials which we are using for preparation of your proximity mode sensing materials. So of course, which we may be used here, such a materials, of course. I maybe close this fundamentals by the reading such a application which we know well that are lacks of linearity and lower bandwidth compared to photodiodes, also less suitable for measurements. Applications are switching applications, high current gain which can be used in the different applications. What are those applications are? The applications are switching applications, high current gain, photo Darlington's gains up to 1 lakh available. So where we can also see here used in the photovoltaic sensing for industrial applications, chilled mirror hygrometers is used here. So let me to so it's also materials which we have gone through right now, but let me go for the usage of such a materials applications also. As we have gone through the so far some fundamentals about semiconductor materials, how can we prepare and how can you design? But those right now it is a conventional mode which we can prepare based on our laboratory knowledges. And but today, artificial intelligence is a field, is a subject, is the matter to involve in any field of works. That is, semiconductor right now we are preparing not for one area. We are preparing such a semiconductor based materials, semiconductor based design circuits for any type. In the sense, wherever, anywhere, any field, automobile or mobile field or TVs, such a or cameras, everywhere today we are using completely semiconductor circuit based only. But today, the manually we are preparing in terms of conventional mode. It's having more what we call disadvantages while we are preparing in terms of conventional. What maybe the disadvantages are that are I repeated while we are starting the today's session. Those are number one. We cannot find out the fault which may be happen while designing. So for the fault diagnosis, for the application of such a fault tolerance information, we need the artificial intelligence, which is right now we are using for the semiconductor side. Another one is where we are using such a semiconductor design for memory devices. Of course, you may be having today such a memory devices are not be limited. It limited based capacity of storage based on different technology. You may find with a little bit cost, very cheap and best 1 terabit pen drive. How can we prepare such a materials based semiconductor memories? In the sense, we are using different types of materials for the like generally maybe based on micro circuit or nano circuit based materials we are maybe using for the storage of instead of simple storage we may be stored even beyond 1 terabit also. Of course, how it may be involved such a artificial intelligence or the subset of artificial intelligence is a machine learning or the subset of machine learning may be a deep learning. How can we apply this actually? So we may know the meaning of artificial intelligence which we can apply here in terms of involving leveraging artificial intelligence and machine learning techniques to optimize the process like chip design, defect detection, that is fault detection, manufacturing efficiently, and produce the product in terms of high performance production or in any type of semiconductor industry. By the understanding of today our complete discussion now, which I'm delivering right now, the predictive maintenance based semiconductor material which will be prepared by using A or ML models in terms of maintaining manufacturing and reducing the downtime and improving the productivity. where this defect detection also happen by the help of this machine learning algorithms towards to analyze the higher resolution images which we are using here, color images, color in the sense color sensors, which we are discussed already, red, green, and blue, towards detect the defects in semiconductor wafer during production. The third point is where you can also consider such AML in terms of chip design automation. Automatically, your IC will be designed. What does it mean chip design? It is an integrated chip. The chip which is we are preparing while preparation for a particular application, we can prepare such a IC in terms of fabricating of all components on a single chip. That is called the IC. That is called the chip design. That will going to be happen in terms of automatically design such a chip, whatever you require. As you are also aware about today technology, by compare with the Apple company of preparation of such IC technology with Tesla. So Tesla is right now is one of the competitive company for the preparation of such a chip design by using AI technology. So this artificial intelligence technologies, how can it involve such a chip design in the sense AI accelerates a chip design by optimizing in terms of layouts, in terms of maintaining power consumption, and also provide the very high performance through generative AI models. And coming to the and this application of artificial intelligence and machine learning techniques in terms of optimize the chip design, enhance the manufacturing process, and very easy to improve the finding of defect detections for efficient and high quality semiconductor productions. So, what are the high quality semiconductor productions are? If suppose you are want to prepare a photodiode, suppose you want to prepare a photo transistor based devices, some pin diode based devices. Those we can prepare by the using of such AI technology in terms of high quality semiconductor. Now, and one more important point is here, of course, I may be encouraging all of you the based on the importance of today AI, how it is entering into the every field, especially industries, usage of that AI for designing of semiconductor designs in terms of overall in AIML is transforming semiconductor design process by improving the in aspect of three parameters. Number one, efficiency. Number two, accuracy. And number four, automatically will be done. Because the technology which we are preparing is semiconductor materials based technology or technical materials. It's maybe nanomaterials based. It may be micro materials based. Such a circuit we want to prepare a conventional way we cannot. It cannot be give good performance. That's what we are automatically go through in terms of AI based design semiconductor materials design is right now automation. And second point, which we can concentrate in terms of high quality semiconductor productions, also concentrated on based on data driven semiconductor design, exploring the role of data pre-processing, feature engineering, as well as the algorithms which we are using in terms of analyzing semiconductor manufacturing data also. The way you are prepared may have fault testing, may have testing material. That's what today VLSI testing is the major subject while you are designing such a semiconductor based materials, so semiconductor based design. So VLSI is of course one of the chip which is a semiconductor based chip. There we are going to have testing, VLSI testing. There is one of the subject which we are already every electronics engineering study at as well as in UZ level or PC level. So coming to the Suppose we want to prepare such a what we called such a semiconductor device based for design. How can you maybe proceed? How can you maybe proceed? Let me to read one of the simple principle of AI technology, which is based on our semiconductor materials design, maybe a pin diagram, maybe a pin diode or phototransistor. What are the equation we may be? If suppose you have gone through the phototransistor, you are concentrating on IC, that is collector current, where your beta value will be changes based on optimistic characteristics of the value of your semiconductor material. How can you find that relation? IC is equal to beta plus 1 of your voltage relation, in the sense by the help of in terms of AI technology, how we are applying is linear regression model. So we are preparing such a linear regression model for that based on that mathematical equation. We can prepare it based on our hands-on experience or knowledge, which is by preparing a program. So let me to explain this program, which we can understand in a simple manner. Write a Python program to perform a linear regression to predict wafer defects. So that we may be using here in terms of NumPy, one of the import for library uh, data sets, and sklearn dot linear model we may import into the linear regression. So your sample data defected in terms of manufacturing of the parameters, as I may be defined that the NumPy array values which we are defined in terms of your equation based parameters only. You see here that notepad based semiconductor information which we may collected from one of the what we called simple value. Of course, by rating this program, we'll get this all the values. What is that? Let me to read the parameter value and the defect density, how you may be find out. Defect density, you are finding linear regression. The meaning of linear regression is, as you all of you know, a linear equation, that is y equal to mx plus a. Similarly here, based on you are preparing of semiconductor material, maybe photo pin diode or a photo transistor or whatever may be, so that relation of the equation which we may find in terms of IC is equal to. So that we are finding here, x-axis you are considering always time value, y-axis will be considered on always either current or voltage. So based on x, y, we may fit the model. Model is here equation model. So we are predicting the your defects in terms of wafer defects we are finding. So once we will proceed to find the defects in terms of prediction mode, then the predict the defect density for a parameter is equal 4.0 value. So based on your preparation of that, you may be find out the predicted defect density is the value 27.80. But the density parameter value is 4.0. But you got it 27.8. So what is the difference between this 4 and here 27 in the sense? Yes, we are concentrated by the help of AI technology, nothing but linear regression process helped us to predict the density prediction. So once we may be used such a what we called simple algorithm of AI technology based on your mathematical model. But whereas if you go to the third point about this high quality semiconductor industries preparation of semiconductor design materials are based on AI in circuit design automation. AI techniques for automatic circuit design and optimizing layouts. How can you prepare it? Yes, we can prepare it by the help of writing a program, and that program is obviously Python. Okay. Of course, we can prepare this Python program, not only Python but MATLAB based also. But Python is more suitable because we have a lot of data sets while we are applying the Python toolbox. So here we are using the Python program once again in terms of AI in the circuit design automation for component placement optimization. Let us take this syntaxes here import numpy as np, import numpy for numerical operations from generate from genetical algorithm in terms of import genetical algorithm as GA. The fitness function is here using minimize wide length defect fitness value that we are going to be use the observation of the value of xi of I plus 1. The range here that x will be vary depends upon your simplified the equation. The components in layout we can also keep. Of course, the components, for example, you may be using pin diode. The pin diagram is P, I, N. There are the three. So those three values we are keeping in the on your layout and we proceed. But here I am using with the help of np dot array 0 comma 10 5 in the sense 5 is nothing but your components in layout. And we may proceed to find that variation of optimized layouts are maximum iterations we may be keep in terms of 50. And coming to the another important point is here. So how you may be find that the semiconductor material based characteristics as I shown now in a conventional way. Yeah, we can find this by the help of your best solution found in terms of Python. That is, you're keeping your object function is your either pin diode or the diode transistor based or the way we are going to be keep your different materials based process. The objective function once you have used it and you proceed that object function based on now different values we can apply. But here we are concentrating on optimum level. That is the optimization technique compared with your AI. I called so far I have been discussed in a number of way of how can you compare AI technology with conventional in the sense there are some of the techniques which we called soft computing techniques is GA. GA is a genetic algorithm. It is one of the optimized algorithm where you can use to understand in between the variables of the equations are various whether your required temperature maintains radiations of the temperature will be maintained perfectly or not. So once you maintain that and you may be reached your optimal level. That is the meaning of optimized solutions which we are using. I hope you may be getting here the meaning of number of iterations and objective function is here. The objective function which you are considered based on your selected semiconductor design basically. And the second one where you can use this genetical algorithm is here. Also having in terms of mutations, mutations process. So that mutations are compared with the our age. I hope you are following me. And here, of course, so far we have gone through the three of the algorithms based on this AI and its comparison with the genetic algorithm, where soft compute technique. But let us see the deep learning for chip defect detection we are using. How can you use it? How can you use the deep learning? Of course, you may know the meaning of deep learning is here deep neural network. As you already know, the meaning of neural network is a layer based network where it can be concentrated to process the information from input to output by the adjustments of weight vectors with bias additionally. So here, such a neural networks we may be apply by the concentration in terms of conventional neural network. So that means deep learning may concentrate the different neural network architectures. As you know, the different neural networks are concentrated in terms of different classifications. Number one may be feed forward neural network architecture, or feedback neural network architecture, or Jordan neural network, or multi-layer neural network, perceptron neural network. What are those? Those are the neural networks which are used for preparation of your deep learning. The meaning of deep learning is here we are going to be get your optimum solution based on the number of layers which you can be increased in terms of achievement of number of epochs. I hope you are seeing here my screen where we are preparation of deep learning for chip defect detection by the help of CNN, convolutional neural network. Convolutional neural network is a feed-forward neural network. It has its own three types of layers. One is conventional, another one is the way you are keeping in terms of average filtering process, and third one is fully layer conventional neural network. So based on the three layers, we may prepare a model for the sake of simple program that is on CNN model on synthetic vapor images finding. So this is the program which I found for the industries where they are using for synthetic vapor images process. As we all of you know, this is the tabular column which we are using number of layers based on the expected output. If if you are using conventional layer in terms of 2D, then your values of output shape is like this. And of course, maximum pulling layer, that is the second layer actually. CNN second layer is this 31, and next to filtering process, next to density, next to fully density. So these are the layers of your CNN. Based on these layers values you can be adjusted, then you are going to get your output. That is the meaning what we can understand from this simple program. Uh, and we got the sample database characteristics based on this layer. We got this. What do you mean this? This is the semiconductor synthetic vapor images data sets which we are using for the classifications of your original data sets, and due to your what we called while we are preparing such a semiconductor connections in terms of PIN diode. P means your P layer, I means intrinsic region based layer, and N region layer. By connecting three together in terms of oxide metal process may have some defects that we find in terms of vapor images based on this data classifications. Of course, you understood these characteristics which are we are using in terms of the x-axis versus y-axis. So values which are varying depends upon the layers. And also I extend one more AI technology which is we are using based on deep learning that we call as LSTM. So LSTM is one of the type of where we can use our deep learning in terms of subset of machine learning, and it also used for the time series forecasting for maintenance for maintenance the good performance. So LSTM is one of the where we can use towards to maintain the some series of data which is right now we can use in terms of your objective function of LSTM, in terms of model that is sequential model, and we may get your accurate results by the variation of number of layers. The number of layers are here 10 at one time, 10 at second time, and accurate of results you can see the lossless value is 0.3, that is a very less error, and 75% you are getting your approximate 75% you are getting your results. That is the meaning of your iterations by using these values. So of course you are so far you may be gone through the how this AI now used in semiconductor design, Let me to extend one more technology which is called based on AML is reinforcement learning. You may be notice this reinforcement learning. So last but not least, that AML in semiconductor design is the feature of AML in semiconductor design, where we can understand previous slides which are discussing terms like reinforcement learning for chip placement and quantum computing and AI added in terms of lithography. So these are Uh, of course, these are the very important points where you can be reinforcement learning process also. I want to clear here one more important point. Reinforcement is nothing but it is a semi what we called as semi supervised learning method or limits overcome by the using of reinforcement learning. Simply, we can apply by comparing with deep learning with this reinforcement learning process. Is here we are applying in terms of in two way or in two modes of process while you are designing semiconductor material. What are those in the sense? Maybe award or punishment. If you design your semiconductor in a perfect on the chip placement, then you may get your result 100% good performance. That is called award. That is called reinforcement part of learning. And when you may be not at done 100% or expected based performance, then it may be failure in terms of reinforcement. So that means the process of evaluation of performance is a easy manner to achieve our what we call say AI or ML based semiconductor design. And whereas today technologies, quantum computing processes also happen while you are designing semiconductor design based on different materials. And also, you can extend this reinforcement learning for AI aided lithography process. Of course, time is not limited. So of course, time is not sufficient to extend and go in detail about this AML. What are the feature technology maybe used for the uh, preparation of AI materials or a semiconductor design materials. So that's what I want to conclude here based on some more points which you can interact with me based on the complete discussed from around 1 hour. I hope you are all understood and by seeing by observing my discussion. I'm stopping here and I am handing this session to our organizers. Thank you, sir.
Thank you so much for the wonderful session, sir. Really, it's very informative, and I know the time is very limited for you to present the whole gamut of the information. But we are very happy. Our participants are also very happy. So I would like to extend our heartfelt thanks to Dr. Polaya sir for graciously agreeing to substitute for Dr. Asadi sir at the last minute due to Dr. Asadi's unforeseen health issue. Your willingness to step in and share your expertise with us is truly appreciated, sir. Once again, we thank Polaya sir for graciously accepting even in the last minute.